Okay, good evening, folks. I received a couple emails today about questions for the Bond Energies practice worksheet. You may not be there yet, and that is absolutely fine, but I thought I would give you some helpful hints on 1B and 2B so you can roll forward. And number 3 is real similar. It's just in the form of a paper 2 type question, which is an application problem. So first and foremost with all of these, all you're doing is you're writing the balanced chemical equation and then listing the value that you find in the data booklet. No real math required. So for 1B, it says you want to write the equation to describe the enthalpy change of formation from the component elements for the following compounds. All that means is how are you making chloromethane from its elements. All of these are going to contain carbon, hydrogen, some are going to contain oxygen, some are going to contain chlorine, and some are going to contain nitrogen. And you got to remember your diatomics. So, in order to figure out what the formula is, I go to the data booklet. And here's my data booklet. I'm on table 12. And what I'm looking for is chloromethane. And there's chloroethane, so right above that is chloromethane. And my formula is CH2Cl, and its enthalpy of formation, when it's formed, it will release 82 kilojoules of heat out into the surroundings. So here's what it would look like in a chemical equation. So what I'm going to do here is I am going to make my line thinner because it works better with my at-home system. My formula, once again, is CH2Cl, and I'm making that from some carbon, some hydrogen, and I need to remember that hydrogen is a diatomic, and from some chlorine, and again, chlorine is a diatomic as well. Have no fear of ice-cold root beer. Have is hydrogen, cold is chlorine. And now I just got to go balance that chemical equation out. So if I'm balancing, I realize that I need 2 chloromethanes, and that means I need 2 carbons and 2 moles of hydrogen. So this balanced chemical equation, 2 carbons, 4 hydrogens, 2 chlorines, is to form 2 moles of chloromethane, but I only want 1. So because these are in moles, I can absolutely divide all of these by 2. And when I divide them by 2, I'm just cutting in half the number of moles that are reacting. So 1 mole of carbon and 1 mole of hydrogen is going to form half a mole of chlorine, or combined with half a mole of chlorine to make 1 mole of chloromethane. And remember, I just looked up on my data table. My data table here says it will release 82 kilojoules of energy. So that's all I have to write. Oops. All I have to write here is standard enthalpy of formation is equal to negative 82 kilojoules per mole. And that's that. So now let's look at 2B, which is not enthalpy of formation, rather it's going to be enthalpy of combustion. So we're going to do the enthalpy of combustion of cyclohexanol. And when I combust something, I am adding it to an abundance of oxygen. And if it's a hydrocarbon, it will always combust into carbon dioxide and water. So if I go back to my data booklet and I scroll down, table 13 will have your enthalpies of combustion. And there it is, cyclohexanol, C6H11OH, and it's going to release negative 3,728 kilojoules for every mole. Same process, You're just writing the combustion reaction now. So I've got my balanced chemical, or my equation before I balance it, C6H11OH added to oxygen will combust into carbon dioxide and water. So now what I'm going to do is I'm going to balance, and I know that combustion reactions are the hardest to balance because you have so many oxygens. So I start by looking at carbon. I have 6 carbons on the left, so I need 6 carbons on the right. I have 12 hydrogens on the left, so I need 12 hydrogens on the right. And here's where our sticking point is. I've got 3 oxygens on the left. I've got 12 plus 6 makes 18 oxygens on the right. So what I'm going to go ahead and do is double everything. Now I have to double everything because yes, 3 goes into 18 6 times, but I have oxygens in 2 different compounds, so I can't very well just put a 9 here to make 18 because of this oxygen. So I'm going to double everything. I'm going to make that into a 12, make that into a 12. So I'm going to have 12 CO2s, 12 H2Os, and I need to double this as well to make 2 cyclohexanols. So now I've got 24 plus 12 makes 36 oxygens on the right. I've got 36 minus 2 makes 34 oxygens. So minus these 2 makes 34 oxygens. 34 divided by 2 makes 17. So there's my balanced chemical equation. But remember, I need to do the enthalpy of combustion for 1 mole. So I'm going to divide everything here by 2. And when I divide everything by 2, that's my husband drilling in the background. I apologize if you can hear that. It turns into 8.5 moles of oxygen. Remember, a mole is 6.02 times 10 to the 23rd molecules, so it's really easy to divide that by 2 to make 6 moles of CO2 and 6 moles of H2O. And my change in enthalpy of combustion is negative, and I have to relook this up, negative 3,728 kilojoules for every mole. So again, the problem number 3 is real similar to this. It just pieces it out like a paper tube problem. I hope this helps, and I will see you on Tuesday, and or email me if you have any questions.